Dear students, welcome to the knowledge series on Semaphore. Before I discuss on Semaphore, let me discuss on the critical sections. Now, what exactly the critical sections means, and what are the how this critical section problem is actually being used in the Semaphore to resolve. Critical sections, set of instructions that must be controlled so as to allow exclusive access to one process. Rarely, access to the critical section is limited to n process instead of one process. Execution of a critical section by process is mutually exclusive in time. Now, what exactly this means? Let's take this is a process P1 and this is a process P2. Now, the process P1 starts from the point, initial starting point. Let us take that at arrival time is 0 and it ends by, say, after a 5-unit time. Now the next process P2 will start at 5-unit time, after 5-unit time, and it will go depending upon the unit time. Now when the process P1 is running, at that time the process P2 cannot start from the same interval. So to isolate the process P2 from P1, we have to use certain methods, thereby these particular critical sections can be put for the process. That means when a P1 is running, so this is a critical section region. At that time P2 cannot enter, or when the P2 is running, P1 cannot enter. Take an example. For example, you are in a room and you lock the room, and you are using that particular room for your purpose. So when you are entering into that room, you lock that particular room and use that room. After that, once you are coming out, then the second person will be entering into that room. So that means when you are entering into that room, that is a critical sections. So automatically the P2 will be the next person will be waiting. When you are coming out, the next person is entering into that room, and then that section becomes a critical section. Exactly in the same way, it is being shown here. Repeat entry sections. That is, a P1 is on. That means when the P1 is in the entry section, P2 is not allowed. So the P1 is in a critical sections. Exit sections. Who is exit sections? P1 is in the exit sections, and P2 is being reminded that you are entering into critical sections. I repeat again. P1 is in the entry section. At that time, P2 will be in the waiting sections, and it will be only not allowed to enter into critical entry section, because P1 is already in the critical sections. That's why because of this one, the P1 is in the entry sections and P2 is not allowed. When the P1 activity is over, P1 is coming into exit sections. So in this case, I put as P1 on, here P1 off. When in the exit section has occurred, then what happened? The P2 is active, and here P2 was not allowed. P2 is acting. Now what is happening? P2 is entering into critical sections. Thereby the entry section is allowed for the P2 sections. So this is the P2 sections. So when in the exit section, P2 is being already given the reminder that you are going to enter into entry section. So entry section, that is a critical section. Exit section is a reminder. Critical section for P1, reminder section for P2. So this is what mean critical sections. Now let us see what semaphore means. Semaphore is to solve the critical section problem. So that is what this problem, when the P1 to enter, when P2 to enter, this problem to solve is basically used by the semaphore, is to solve the critical section problem. There are two type of semaphore: binary semaphore, that is a 1 and 0, and counting, that means minus infinity to infinity. Consider a function in the boundary which is to access the two process P1 and P2. Consider this is one function P1. Let us take that you are writing a one program in C, and you are calling it to subroutine, and the subroutine is having a two process, a P1 and P2. Let us think that P1 is assume like some push button, and P2 is something like some trigger. So these two process. So whichever is activated first, that will be given preference. And once that one is over, then only the next one is. So let us take like that one. So P1 and P2 is two process. If the P1 want to access these functions, so automatically P1 will go into critical sections. At that time P2, I have shown as a dotted that P2 will not enter. And once the P1 is completed, because P1 is inside this boundary. Boundary is a critical section. I put it as a boundary. This is a critical section. So once the P1 enter, P2 is not allowed to enter. Once the P1 is completed, P1 will come out, then P2 will enter into critical section. At a time, one process can enter into critical section. To solve the critical section problem, three criterion to solve. The first is a mutual exclusions. That means one process can enter. There should be understanding that one process will be able to enter, other will be in the reminder or in the waiting mode. Progress. The process that want to enter to critical section should do the race. P1, P2, P3, P4, P5. Let us take. So we have discussed in the class about starvations. The process which is having more active and energetic, it will be given the more preferences, and those who are less energetic will be waiting in the queue, and thereby they will be going for a starving. So that's what it means. So the process that want to enter should go for a race. So here the tick is indicating that they need on race, and this is given they no need for a critical section. So P1, P2 and P5 is shown here. They are in the race. Bounded wait. Process should wait a bounded time instead of the whole time to avoid starvation problem. That means you cannot allow the particular process to stay beyond the completion time. Otherwise, the next process will be starving. So every process is having certain predefined times. So that is what called as a bounded wait. If a process that meet the above solutions using a semaphore is a solutions. So if you can able a semaphore meets these three conditions, then that particular process problem of the critical sections can be resolved. Now what semaphore is? Semaphore is an integer variable. You have to understand this is an integer variable number that solve the critical section problem. After initializations, it can only be accessed by two atomic operations. After initialization, once we start the semaphore, it will be going based on the atomic operations. We have talked about atomic time in the module 2 when we were talking about the various schedulings. Now, as I stated about this initialization of this integer, so take an example, int s. Now, say s is equal to 1, s is not equal to 2, s is not equal to 4. To change such a value, wait and signal to use. What I mean to say is that this s is equal to 1, 2, 4. These are nothing but an integer variable based on this integer flag representations. Automatically the process will understand that which process has to enter and when it has to enter based on the two factors, wait and signal. These two things already we have discussed. The same thing I will explain in a more clear manner the wait and signal is very is the two factor is important for the semaphore to switch between one process to another process based on the condition of the critical sections or the critical criteria I have already mentioned with respect to that under the critical sections conditions. Now weight of S, that is the semaphore integer S. For a while loop is given, if S is less than equal to 0, then S is equal to S minus 1. On the other hand, signal case, if S signal of S case is given, S is equal to S plus 1. That means whatever is the S is here, the same S will be used to find this while loop conditions, and thereby will determine this S. And this S value will be used here. That is what I mean to say. I have mentioned here example. Say S is equal to 1. Then S is equal to, if S is equal to 1, that means this conditions, if it is not met, then S is equal to 1 minus 1 is equal to 0, then automatically it is going into the true condition. Say S is equal to 0, then while loop will be keep on rotating as it does not have a body. So if S is equal to less than equal to 0, what will happen? This will keep on rotating. So that means that particular process will be in the critical sections. So whenever the S is equal to 0, it will keep on rotating in this particular process. You keep this one in your mind. Okay. Now when the S is equal to 0, this one, the moment S is equal to 1 has is occurred, so automatically this will become 0. S is equal to 0. So when S is equal to 0, it will come here. So here S becomes 1. That is what, then S is equal to 1. And if it is a 1, it goes to 3 like that one. That I mean to say. This is for your understanding purpose I put it. Now here the weight operation is given as a negative, that is it is reducing the value, and the signal operation is for a additional value, it is increasing the value. To understand this weight and signal, I have another pictorial representations. Let's understand this one. Now let us take I have put the 4 process P1, P2, P3, P4. Now the program code is, first let me explain the code 1, wait, do, wait, signal, reminders and while. So that means wait, do, and here I am giving the while conditions. That is what I mean, this while S less than is equal to 0, S is equal to S minus 1. If it is false, if it is true, automatically it is trap, otherwise it will go into the other conditions. So this S less than is equal to 0, S is equal to S minus 1 is coming here, just remember, and S is equal to S plus 1, it is coming here. Are you getting my point? So when this condition is coming, when S is equal to 0, it is in the critical sections, and when S is equal to 1, automatically it will come here and the signal is activating. So this is what I mean to say. Let's see from here. Let us take a case that S is equal to 1. Let us take S is equal to 1 is coming. So automatically if S is equal to 1 is, first take the case S is equal to 0. If S is equal to 0, what will happen? This condition is fulfilled, then it will be in the trap conditions. That means this while loop will be in that particular case. Now when the process P1 is in the critical section, when the S is equal to 1, when S is equal to 1, what is going to happen? S is equal to 1 minus 1 is equal to 0. So that is what indicating that the process P1 I am putting as a true case is that the process is going to switch over from the case from the process for the next process of the waiting. That means when S is equal to 1, that means S is equal to 1 indicating that process has to go from the critical section to the waiting sections. When S is equal to 0 means that process is running. When S is equal to 0, process is running. When S is equal to 0 means what? This while loop is in the trap conditions. It will not go further. When the S is equal to 1 comes, automatically the process is going to S minus 1. So 1 minus 1 is 0. Whenever 0 is there, automatically this process has to come out. When the process is coming out, at that time what happens? This S is equal to 1 case, it becomes 0. So this 0 where it goes? It will go to signals. It goes to signals means what happened? S is equal to 0 plus 1 is 1. So that is what I have shown here. Once it is 0, it go to the signal case. 0 is there. Sorry, S is equal to 0 case. So 0 plus 1 is 1. So automatically process is going to false. That means the process is making this particular process for the P2 to active. P2 to active. When the P2 is active here, that means P1 is inactive case, P2 is active. So that means first it was waiting, then it has gone to signal case. It has gone to signal case. So automatically when the signal case, P2 is active. Now here in this case, S is equal to 1, P2 is active. Now when S is equal to 1 case, P1 is inactive, and in this case S is equal to 0. S is equal to 0 indicates that because it is 0 in the case of a P1, indicate that the TP2 is coming into the active, that is the P2 is working. When P2 starts working, automatically after some time the P2 will go into signal state. So automatically when the P2 will go into signal state, what will happen? Automatically it will become 1. So automatically this 0 will come. 0 plus 1 is 1. So when it is come to 1, P3 is active. P3 is active. So P3 is active. When the P3 is active case, why it is P3 is active? Because this 1 P2 becomes 1. So 1 case 1 minus 1 is 0. So TP3 is 0. So P2 becomes inactive. So false is indicating that particular process is inactive. T indicate that true inactive. So in nutshell I have to say like this one. Whenever the true is active, that means that S is equal to 0. Whenever F is showing inactive, that case S is equal to 1. So that means whenever S is equal to 0, that process is running. When S is equal to 1, it is indicated that is inactive. That 1 will make 0, and that 0 comes here, so it equal to 1 to make that particular process of a P2 process to inactive, and thereby this process will enter into this particular mode, and here it becomes active. So this is what I mean to say. Solution to the critical section using the problem of wait and reminder. So every time the process P1 comes here, it comes as a 0 and it goes as a 1. When it goes as a 1, so it becomes 0 here. So like that the entire process. So when S is equal to 1, and that is what I mean to say, it becomes 0. When it is 0, P1 is active and P2 will wait, and when the condition of this S is equal to 1 has to, if it has to satisfy, then in that case this process has to go into the 1 mode, and automatically when it is in a 1 mode, automatically you will see that here it becomes 1, it becomes 0, and this 0 plus 1 is 1. In this indicates that S1 is equal to 1 is indicate that this process is coming out, P1 process is coming out, and here the P2 process, because P2 has got S is equal to 0 in the signal, that means again I go back. When the weight is for the P1, this is for P2. So when weight is having S is equal to 0, so here it is 1. Automatically P0 is P1 is active in the P1 in the critical section, P2 is not in the remainder section, because here when it is 0 it is 1. So when it becomes 1 here it becomes 0. So in this case P1 is inactive or remainder section, P2 becomes critical section. Like that the switching over relay. So 0 1 1 0 0 1 1 0, like that it is given. So this is what exactly the meaning with respect to the critical sections. As the name indicates, this is one of the important questions that normally appears in the university question papers. Thank you.